doing trig. The next lesson we're going to cover today is lesson 18. It's on advanced word problems. Now, if you guys were here, I would hand you this printout so you don't have to spend all this time writing words. But again, you can print my notes. But we are going to be doing some advanced word problems. And I printed them out so we can write directly on here. So here we go. And if you want a copy, just tell me. I can email you a copy. So here we go. We're going to jump in. Now, advanced word problems is meaning we're probably going to be solving for 3 variables. And you're going to have to be able to set up those equations based on what they give us. This is not review. Okay, we did not do this in Algebra 2. So here we go. The number of blues was 4 less than the sum of whites and greens. So there's equation number 1. Blues was 4 less than, meaning that should be at the end. Less than means it needs to be after the sum of whites and greens. Okay, so notice I'm using B for blues, W for white, and G for greens. Next sentence, the number of greens equaled the sum of blues and whites. So there's equation number 2. So number 2, greens equaled the sum of blues and whites. So sum would be adding, right? How many of each were there if there were twice as many blues as whites? Now that's actually probably the trickiest part. And you're going to have to set it up based on common sense. I know that there's twice as many blues as whites. So most people want to say 2B equals W, and it's not the case. Blue equals 2 times W. Now, that's opposite of kind of what it's not opposite of what it says, but it feels opposite when you're setting up. They're saying that if I had 20 blues, I would have 10 whites, right? They're saying that blues would be double. And the only way that would work out is this equation right here. 2 times the W's will equal the blues. So be really careful how you set it up. I always pick like real numbers and check my equations to see if they work. Now from here, I'm simply going to use some substitution to figure this out. So you can use a combination. I would use substitution and elimination to solve. It's whatever fits. So for example, I'm going to substitute, if I know B equals 2W, I'm going to substitute that right in there. So the number of greens equals 2W plus W, so G equals 3W. Okay, and then from there, I'm going to continue to substitute. So I know, check out this first equation, I know that the number of blues, and it says right here, equals 2W. And then I have W plus G, but I know G is 3W minus 4. So this gives me the ability to solve for my W's because I substituted 2W into B and 3W into G. So 2W equals 4W minus 4. Negative 2W equals negative 4, so W equals 2. So I found the first one. From there, I'm just going to keep substituting. So blues equals 2 times W, so blues is 4. And for some of you, I would bet the setup is the hardest part. So, oh wait, now I'm solving for G. So G equals 4 plus 2, so G equals 6. So there are the 3 values. All right, moving on. Quarters, nickels, and dimes. Now this one's tricky because it requires you to know how much they're each worth and assuming that you can set that up. And it won't say, hey, set them up for how much they're each worth. It won't say that. So let's start with one equation at a time. Quarters, nickels, and dimes total 20 coins. So that's my first equation. Quarters, nickels, dimes equals 20. Their total value was $1.90, so that's going to be second equation. Now I'm going to keep all my money together. I know that quarters are worth 25 cents, which as a decimal would be 0.25 Q. Nickels are 5 cents, so 0.05 N. And dimes are 10 cents, and they're telling me it equals $1.90. So notice they didn't tell me their worth. You need to know that if they mention how much they equal, that you then plug in their monetary value. Last, how many of each were there if there were 4 times as many nickels as quarters? Remember, this should be set up opposite of what you think. 4 times as many nickels. That means there's more nickels. So nickels would equal 4 times the amount of quarters. Okay? 4 times as many nickels as quarters. So there's way more nickels, and the only way I could set that up is the smaller number has to go here. So if I had 2 quarters, I'd have 8 nickels. So try to plug in numbers to make sure that that works. From here, again, I'm going to use substitution. I'm also going to get rid of my decimals because I don't like decimals, but we'll do that in a second, okay? So let's start with, I don't remember where I started when I did this problem. Where did I start? The first thing I did was to get rid of the number of my decimals. So in order to get rid of the decimals, I look at the last number. So I have a number here in the tenths, hundredths. So because I have numbers in the hundredths place, to get rid of them, I'm going to multiply by 100. And I'm going to write my new equation here. Now when I multiply by 100, just move the decimal 2 places over. So that would give me 25 quarters plus 5 nickels plus 10 dimes equals 190. Much easier to deal with. Now, because this bottom equation only involves Q and N, I want to eliminate D. So notice this excludes dimes, so eliminate D from the other two equations. And I'm going to do that using elimination. So I'm going to multiply this first equation by negative 10 and write it here. So negative 10Q minus 10N minus 10D equals negative 200. Simplify, I get 15 quarters minus 5 nickels equals negative 10. Okay, now from here, I'm going to use substitution. I know that N equals 4Q, so I'm going to substitute 4Q into N. So 15Q minus 5 times 4Q equals a negative 10. So I have, and did I do that right, 100? That's 190. Negative 10 times, I want to make sure I have that right. Should be right. So this gives me 15Q minus 20Q equals negative 10. So negative 5Q equals negative 10. So quarters, there are 2 of them. If there are 2 quarters, 4 times 2 means there are 8 nickels. And I know that I have 20 coins in total. So 2 plus 8 is 10. That must mean that I have 10 dimes. So once you solve for one, the rest should be pretty fast. Next one. All right, so let's set this up just like we were. Reds vary directly as blues squared and inversely as greens. So that's equation 1. So reds vary directly as blues squared and inversely as greens. Okay? That's a review of direct variation and inverse variation. Okay, next one. Oh, sorry, that was equation 1. Where there are 80 reds, there are 4 blues and 2 greens. That's equation 2. Where there are 80, oh, and there should be a K, sorry. Where there are 80 reds, there are 4 blues and 2 greens. So that would be 16K over 2. So 80 equals 8K, so K equals 10. This is a review. If you need to see it, direct variation is y equals K times X. Inverse, this is just review, y equals K divided by X. So that's where I got my original equation. So then I'm going to solve for how many reds were there when there were 8 blues. So R equals, I know what K is, 10 times 8 squared divided by 10. So that is happening here. And you're simply solving. So R equals 8 squared because the 10 over 10 cancel. So R equals 64. Okay. Moving on. Again, you can always pause my videos. All right, these are nobody's favorite. Everybody hates these. So here we go. These have to do with a lot of, you've taken chemistry, kind of similar problems here. So to get 1,000 gallons of mixture that was 56% alcohol, it was necessary to mix a quantity of 20% alcohol solution with a quantity of 80% alcohol solution. How much of each was required? Now I'm just going to let you know that I'm going to use X for the first alcohol solution. And I'm going to use Y for the second. Okay, so just so you know, so you see it. So they told me to get 1,000 gallons. So I know that X plus Y must equal 1,000 gallons. And they told me that I was going to have to use a mixture of the following. So it was necessary to mix a quantity of 20%. So 0.20x is going to be my first. And 80% alcohol will be my second solution, so plus 0.80y. And that was to get a mixture that was 56%, and I know it's of 1,000 gallons. And so I am going to have to do a little math there. The 56% is of 1,000 gallons. So I'm going to simplify this equation here. This is 0.20x plus 0.80y equals 560. And then I'm going to use some substitution. So x equals 1,000 minus y. And that way, that is probably the fastest. I'm going to plug that in here. So 0.20 times 1,000 minus y plus 0.80y equals 560. Again, setting it up is the hardest. And then that gives me 200 minus 0.20y. I'm going to combine like terms, and I'm going to subtract 200. So 0.60y equals 360. So y equals 600 gallons. And if y equals 600 gallons, I know they add up to equal 1,000, so x equals 400 gallons. So I realize that one is kind of crazy, but use my notes to help you out. The weight of carbon in a number container, and it gives you the value of each, was 113 grams. What was the total weight of the compound? Let's start with C. It says it weighed 12, so that would be 12 times 3, which would be 36. H7, it says H has a value of 1, so 1 times 7. And I am guessing that's chlorine. I don't know, though. I don't remember chemistry. And it doesn't, I'm going to assume there's an invisible 1 there, and it says 35, so 1 times 35 is 35. So if I add these up, I get 78 grams. it's asking what the weight of my carbon is. So I know that, where did I set it up? It wants to know the weight of carbon, which is C. So C is 36, must be proportional to 113 to the total weight of carbon. Now C, I know what, C is to 78 as 113 is the total. Now I know what C is, so I'm then going to plug this in to be 36. And then I'm going to cross multiply, so 36 times C equals 78 times 113. So 36T equals 8,814. So the total carbon is 244.83 grams. Now, homework 18, because that's the end of this lesson, just covers complex word problems. The end for homework, I'd like you to skip the following. I'd like you to skip numbers 5, 8, 11, 12, 14, and 21. And that is it.